Biljana Makedonska, Paneva. I'm from Deutsche Telekom, but Deutsche Telekom is a big group working worldwide, and all around the globe we have many artificial intelligence solutions. Just to navigate the audience, I'm from Telekom Deutschland, the customer service, and there I'm working as a business owner for voice analytics. It means I bring use cases from dealing with customer voice, the conversations that we get on inbound calls in our call centers. Of course, we have other channels to communicate with the customers, but these are really dominant for the time being. Just for orientation, we speak about 30 million calls annually of relevance without some segments that are not relevant for this use case. I'm business epic owner, so I bring with me a couple of, let's say, business perspectives which come on top of the technical requirements for the solutions. The technical requirements are the basics. We need a solution with good performance in terms of latency, speed, whatever it is. But after that, we have some additional requirements from and challenges from the business. So what we see on this slide is something else in the title, Artificial Intelligence that Humanizes Customer Service. So it's not here by accident. Actually, we deal with customer data, which is a very sensitive topic, and we deal with human-to-human interaction, which is, again, a sensitive topic. And we have to work a lot in the company to improve the internal culture and the external opinions about how artificial intelligence is implemented. Totally not relevant maybe for the technology itself, but very relevant if you want to have successful implementation of artificial intelligence in a corporate environment. So we honestly believe that artificial intelligence in these use cases supports the human interaction, and you will see in the next two use cases how. The other element on the slide is that we work under the motto to turn our customers into fans. That is the strategy, meaning best network, of course, we are in that business, means great product portfolio, and means best service, which is kind of a novelty in the group. And for us, people in service, it means that, of course, we are devoted to bring the best solution out of the box, improve the current solution or whatever it is, to understand the customer no matter which channel the feedback comes from, to solve the problems, if possible, during the first interaction with the customer. It's the famous KPI in the service, the first resolution rate, etc. But it's not enough. It's even expected that we predict why the customer would call us. And this is the part I love the most, because we, the people who are in data science and data analytics in service, can definitely support with our best. Of course, we don't use the ball. You can imagine there are other tools for prediction, but really the visualization was well done. So the two use cases that I bring is first detecting customer contact reasons, and second supporting the agents with search in the knowledge management base in real time. The challenge for the second one is that the analytics has to work in real time. We will come to that. And let's start first with the first example. We said the idea was to predict why the customer would call us, but if you predict something and then the first question you will be asked is, okay, how is it now? And we face the situation that we even don't know how is it now. Why? Because in the existing solution, in the CRM system, there is, from the history, from the legacy in the company, the drop-down table where the agent should click why the customer is calling us. It's three-level drop-down table with around 1,000 combinations. So you can imagine the time consumed, the accuracy, and you can imagine that someone is waiting on the line until we spend time for this. So this step was replaced with artificial intelligence, and this is one of the beautiful examples when we replace manual steps that consume time, and it's not interesting neither for the employee, neither for the customer, and even does not bring valuable information, valuable insight for the management, so it's step useless for everyone in the game. So it's replaced with artificial intelligence that should make it faster and improve it in terms of quality. So the process is quite easy. We record the calls, transcribe them, and classify the transcripts. And based on that, we get at the end the main call reasons. That was the MVP of the project. Until here, I would say that for the first 3 steps is a standardized solution. I can maybe explain later why we do it with this interface and who is working on it. It's a business decision. It's not a technical topic. The interesting part for us is what we do later on when the transcripts come to the data lake, and here we engage our data scientists to enrich the data from the transcript with the data from other sources. Let's say a few words about the MVP, because this is the starting point. So first you need to understand why the customers are calling you, and then we go further. A few minutes maybe on this, why it's important to understand what are the main call reasons. The original reason was from the management. Management tries to steer the business and the capacity of people on most efficient way. So it means if some of the reasons for the customers to call us is caused by us because our processes are not good, our processes are obsolete, or we did not update it certain platform or whatever with bringing new products, it means we should correct it. What does it mean translated for analytics is that the results of analytics should be useful for the business. And I want to emphasize it because the first question that comes to this is there is plenty of softwares around. Click a button and you get the segments, you get the clusters. So of course, every cluster is beautiful. You see the analytics, you see the description. Of course, you find logic there. So of course, they are logical. But the question is which cluster is useful? So it will be only useful if after that we can take some actions. I point this because very often in the companies we kill the analytics by just making some clusters, and then the data scientists say, yeah, but the business is not using them. Of course, the business is not using them if they are not made on the language understandable for the business. So these are the main call reasons. Another thing, main call reasons. It should be, the cluster should be big enough so if you take some action, you have improvement of 1, 2, 3, 5%, which is already a significant improvement. Imagine I started the discussion with 30 million calls arriving per year. So if you improve something for a couple of percentages, that's already improvement. So the list of reasons might be very long. We stay focused to improve the call volume on these main call reasons. So they should be translatable to the processes in the company. Of course, when we start to build the segments, we know approximately what are the call reasons. We know the customers call us because of non-clarity on the bill, moving the line, etc., etc. We don't know the size of it, so that's what should come and to be accurate. One example here is this problem with the self-service. This was detected by re-listening the calls, finding keywords there by the quality management people, because only they are allowed to re-listen a call of a customer in telecom, not everyone. And they are very experienced by re-listening calls and picking up problems with the processes. So they found this one, and surprisingly, it turned out to be quite a big segment. And this is some of the results from this exercise that is useful for the business. Of course, if you have some other segment like customers are calling you to ask for the tariff, that's not a problem. These customers are welcome to call. But when you find something like this, it means you made a self-service platform that originally should offload you from some very simple calls from the customers, and in the same time, this platform generated calls. So this is immediate call for action in the company. So I pointed this out because there is very frequent question about how the clusters are made. The second one, besides having the main call reasons, are some kind of daily analysis. So the daily analysis are, of course, as a size, not like this one. So here, 10% of the call from 30 million is 3 million calls. Here we might have 15,000 calls for Disney Plus package. Not important for management to do some change on the processes, but very important for the product owner and for the campaign manager who is doing that product at the moment. And this kind of analysis are done on daily level. Why I point is because you see the software we are using to do the transcription, the speech to text and analysis is Verint, and they have a interface which is very helpful for us. Why? Because for the first 2 points, actually we engage the quality management people. They are very experienced, very good in making this for us, and they offload the data scientists significantly. Of course, there are other ways to do this in the company. If you have a long list of data scientists hanging, waiting for tasks to be delivered to them. But we don't have that luxury in the company. We engage more and more data scientists, but they are actually appointed to topics like this, predicting and building predictive models when not only the voice analytics data are used, but also data from other sources. Of course, the first 2 tasks can be accomplished by the quality management people. They will be trained to use a software interface, which is easy for them to train and test, etc. So practically they do modeling in a way by using the indexing that is already by default from the there from the transcription, and by doing something that they are not even aware that is a training and testing model. But it's only up to here, it's only based on what is said in the conversation. When we want to transfer the data to the data warehouse and to the data lake, and then join it with more data, then of course we need the data scientists. And here we predict, we combine the content of the calls with the feedback from the customer. We predict the sales intention and combine it with the next best action. We bring the correct contact history to the front-end application, etc. And for me, let's say in the favor of the time, I brought an example only from the 4th one, which is predicting the call intent, why the customer would call us. So here we have the data, which is from voice analytics. That is practically our label, which customer calls for the invoice, for example, for non-clarity for the invoice. And we have a longer list of other data in data lake, like, for example, from the billing, from the customer journey logs, the contacts from the customer, the finance, reminders, dunning process, etc., etc. Of course, the data has to be prepared, the long and painful process, very well known to you. And then they go to normally it's a black box, but in our case it's magenta. Okay. And then what is the result of the predictive model is, let's say, a list, a white list of, from, you can imagine for 40 million customers, you list at the end 100,000, 200,000 customers that might call you for the invoice, no matter if it is not clarity, dunning process, payment, or whatever. So this white list gets loaded where the chatbot or voice bots are, and then when the customer calls, instead of posing the general question, why are you calling us? And then the customer says something, and then we route to the skilled group. In that case, the customer is asked, are you calling us for your invoice or because your invoice is higher or whatever? So there are a couple of scenarios. What is presented here works in practice. It's implemented already. We collect the feedback. The target group is not so big. It's only for one use case about the invoice. So far, the feedback is good, but I say again, we are still not to the level of saturation. We are not to the level that for 50, 60, maybe 80% of the customers, we have already intent prediction. That is the next step. So instead of one category here, to have kind of, 10 or 20. So for the time being, works very good. And because it works very good, the requirement is that we expand it to more contact reasons here. So let's stay now on the architecture, how this works well now, and what is the challenge for expanding it. It works with LSTM cells. We take the data, the events from 30 days history. 30 days depends how you read it. I mean, in our last month history, we already have the information about the delta to the previous month, so you can consider it as 60 months, depends how the data is structured and organized in your data lake. Then, of course, we decided for LSTM because LSTM basically works quite good when we have on the input time series, the data with time dependence. For this case, we use kind of 1,000 inputs because we have only one output at the end. It is invoice, it's not invoice. the first challenge, if you increase here the outputs, would be you need also to increase the input side. So this will not be 1,000, might be more thousands here. Another interesting element here is that beside, of course, beside the embedding layer, which is classic, and we decreased from 1,000 to 64 for data, we added another layer, which is time layer. Of course, the data is ordered chronologically. That's a default, but sometimes similar data might appear the 2nd and the 30th date of the month, and then the importance is the distance. So actually the time layer does nothing but introduces a measure from 0 to 1 in terms of length. And then we tested several layers, 1 to 3 layers. 1, of course, was not so good, 2 was good, and 3 was not so good, was not bringing big improvement. So we stayed on 2 layers. And originally, the colleague who was designing this was strongly believing that the one-directional LSTM will work. It turned out that it works, but much better works bidirectional LSTM. Maybe you have another idea why. Our assumption was that might be, so it's might be, because the order of the things, how we in telecom order the events and how the customers see them, it's not the same thing. At the end, when we get the probability, and of course we have we can select the list for the chatbot and for the voice bot. It's our decision. Shall we take a wider range with a lower precision, or let's say a smaller list with higher precision? For this purpose, we decided after several checks with the colleagues from finance, etc., so that we can go even with above 55%. Of course, this is not a rule for every use case. So we went with quite a long, bigger whitelist, and the feedback from the customers was good enough. So what works? Well, now the target is that we start here to add a new prediction on different events, like different orders or etc. So in that case, we have to bring more data here, and in that case, the LSTM might not work so good as architecture, because we will require really enormous computational power of the iterative process, etc., etc. So the colleagues at the moment moved to build to train the transformer. I cannot tell you any feedback because it's happening really at the moment. We believe it will work well because we'll support bigger series of input data here, and will enable to have more direct results on the output. So very shortly, the takeaways from voice analytics: this is a cost case. It can work even with lower word error rate. Why? Because from 10 minutes conversation, you will find what is the call reason. Low means not really low, but lower in comparison to the machines that are on the market. In comparison to the real-time analytics. Then we use the interface. I explain you why we use the interface. It was practically a business decision, not a technical decision. And legal aspects. I think I can speak here at least 2 hours about the requirements. We speak about the customer voice. So customer voice is identification of the person. In the call, there are confidential data like the names mentioned, phone numbers mentioned. So we have to take care that all this is anonymized, etc., etc. A long list of challenges related to the implementation of the project rather than something that is to be invented. Now, very quickly on the second use case. The second use case has a challenge that has to work in real time. So the previous one, analytics, happens later on. So at least here we are relaxed. Here the analytics should work in real time, because at the moment when the customer calls us, if the agent does not know what to say, he has the opportunity to type in a window in our knowledge management base. And then he gets finds the answer here from this application. It's a knowledge management application. So he has to move to that application and type. So instead of typing, the idea was that the solution listens practically the conversation and understands what the customer is asking and immediately shows the potential link where you can click and find the answer that you are searching for. Of course, you don't have to do it if you already know the answer as an agent, but in case you don't know the answer, you have opportunity to click. Okay, it's not that big in reality because I had to increase it for the PowerPoint, but it exists as a solution. And then the agents do not move from the frontline application that they normally see. This is another example how we humanize customer service. Attention to this because we do not replace humans, we just support the human interaction with something that is avoiding typing or waiting. We did a POC. The POC showed very good results. We did it rule-based. We covered 47% of the calls. Why? Because we know what are the main call reasons. This was the starting point, so then you can easily select rules. On 72% of these evaluated calls, the agents were very happy. We did it as a proof of concept with only 44 agents. So we need to scale it up now up to 9,000 agents. And we have not done it yet. Why? Because of the fourth point. Let's wrap it up quickly. The first challenge here is you don't only process the calls which are with customer consent. You want this to work for 100% of the calls. So that's a challenge. There is, let's say, a solution for it with buffering certain period the call processing and then you delete the content. So you don't record, you don't work based on recording. The second one, the word error rate has to be much lower. So in the previous situation, we had 10 minutes conversation, you will understand what is the call about. Now, you have a situation that as the window is moving in a very short period of time of seconds, you have to understand. So every word counts. So here the word error rate has to be much lower. Actually, the speech-to-text performance has to be really supreme. For German language, by the way, because we speak about Telekom Deutschland, and I believe that for English language, much more tools and software were trained. So this is how I get in touch with Dan to help me with the insights from the German language. And then this is not a cost case. The previous use case was a cost case. You cannot give a commitment to someone in the company to decrease a call volume or improve a process until you don't do the analytics. So you first have to do the analytics, then you split the task around the company. And it was approved as a cost case. This one is already not a cost case because, first of all, the cost is much higher. Just to remind you, we processed 30 million calls on the inbound, so it means that it will have a ticket of the cost that has to be justified in the company, and it's justified in our case with the shortening of the call handling time and decreasing the call forwarding. Finally, where we stopped in this after the proof of concept, because the proof of concept was done in November, so it works well. We did not scale it up because we got a legitimate requirement from the management to try to explore the most of the synergies with other systems where we have processing of the voice of the customer. It means we use the voice for authentication of the customer, and that happens in one software. Then we have one process, etc. Then we have voice bot, that's another system. Then we have voice analytics, and then we come with real-time voice analytics, which means already in 4 different systems with many different interfaces, we work, and the volume of interactions is increasing. So it was a legitimate requirement, try to find the best of synergies between these 4 projects. Can you put it on one platform, for example? And we are investigating that, and in that sense, my message is here that it would be best to have industrialization of artificial intelligence, because for us in telecom, we need one solution that can bring all these 4 together. Not because we cannot do it separately, of course we can do it, we are having them actually separately now, but because voice analytics is let's not offend ourselves, but it's very small part of the complexity of the telecom. The telecoms have networks, they have billing systems, platforms for providing TV, internet, etc., CRM, so that the core of the business. And then when we come with artificial intelligence, it is welcomed in the company, very supported, and we already work on it. But we have to fit within the resources that we have in the company. So that was my, my last message for today, industrialization of artificial intelligence. Now, questions.
So sadly, in the interest of time, we don't really have time for questions. Perhaps if there is one question. Okay, I saw one hand, so that will be the question.
Hi, thanks for the talk. So I saw in your POC, you essentially measure the impact or the success of the project by collecting subjective feedback. I was wondering if you also looked at maybe it reduced the duration of the calls, it made increase the efficiency for the agents in handling the talk?
Yes, exactly. So that will be how we will measure the success. And the success will be measured by measuring call handling time and the call forwarding. But for that, we need certain period of time that the system is running fully integrated. The POC was, let's say, pretty much rule-based, related that this couple of links in the knowledge management base can be connected in a simple table to these contact reasons, etc. So it was not really integrated solution. So first I need to have in place fully integrated solution with all interfaces, with all possible latencies on the way, etc. And then when it runs, I have to leave it running for, let's say, a couple of teams, because across Germany we have different hotlines, different dialects, different whatever. So it has to be really measured on a scale. So I need to bring a couple hundred, maybe people, 200 people to work a couple of months, and then we will measure the call handling time and the call forwarding. But practically it means for me that I have the solution in place, and then it's just a matter of adding a couple of thousand employees plus. So that is actually very expensive part to come to this moment. That's why before we enter into this one, we measure the completeness of the solution from the customer perspective, and that is how the employees, the agents evaluate it. So this is the first step, that they say this solution is as they like it, and then we go into production. So it's a couple of steps in the approval of the solution before we scale it up. For this purpose, actually, it is measuring subjectively by a couple of agents, 20, 30 maybe, yes, that's true. But on the other side, within the company, we have a so-called new products and services group in call center, colleagues that are very, very experienced in working in call center, and they are very supportive that we bring something new. So when they assess our new products, they do not assess it like, okay, we were working previously with something else, it was better just because we are used to work like that. No, they are really helping us, but we also have to pass this step, because if some solution is robust, expensive, and at the end does not really meet the requirement of the customer, we can simply abandon it.
Okay, so thanks again for the very interesting talk. So I guess we can also discuss offline a bit after during the poster session. So
yes,
thanks
around.
a lot.
Thank you.
Thanks again.